To really learn about optionals, let's start out with an example. So let's say let possible number equals 1, 2, 3. And here possible number is a string that could or could not contain an integer. And let's try to convert this into an integer. So let's say let converted number equals int possible number. And let's run it. And great. As we see, possible number was a string. It's something that looks like a string. And converted number looks like an int. To be exactly sure of what the types of these variables are, let's look at what the types are. So let's say type of possible number, and let's look at the type of converted number, and we'll run it. And we see here that possible number is a string, just as we expected. But converted number is not just an int, it's an optional int. Well, what's this optional? Let's look at another example to see what it is. So let's say let possible number 2 equals something like hello. And let's say let converted number 2 equals int possible number 2. And just like the previous example, here possible number 2 is a string that could or could not contain an integer, and converted number 2 tries to convert possible number 2 into an int. So let's try to run this, and great. We see here that possible number 2 is hello, and converted number 2 is this nil value. Well, what's this nil? Nil in Swift is a special value that pretty much means nothing. It means a stateless value. So what we know here about this int initializer is that if you try to convert a number that can be converted into an integer, it does that, no problem. But if you try to convert a string or something that cannot be converted into an integer, it returns this nil value, which means that there's no way I can convert this whatever you passed in into an integer. So I'm just gonna return the stateless value, which means nothing. So let's try to explicitly type these variables. So we know that possible number is a string. Possible number 2 is also a string. And let's say converted number is an int. And let's say converted number 2 is also an int. And we try to run this, and Swift complains. It says value of optional type int must be unwrapped, something. So what Swift is telling us is that converted number and converted number 2 can either be an int or it can be a nil value, which means nothing at all. So it would be wrong to denote this as just an int. It doesn't make sense to just say it's an int. We need a way to say that it could be an int or it could be a nil value. Well, the way to do that in Swift is to add this question mark. Here, this question mark means that converted number is possibly an int. It could either return an int or it could return nothing at all. So that's what an optional means. An optional is a variable that could either have an explicit type like string or int or something like that, or it could have nothing at all, a nil value. So another way to say a variable is an optional is to say it's possibly of this type. So let's say you wanted to add 2 to this converted number. So let's try doing that. Converted number plus 2. And let's try running it. And Swift complains. It says value of optional type int must be unwrapped to a value of type int. What Swift is telling us here is that when this program is compiling, we don't know whether converted number is an int or a nil value. From running this, we know that converted number is eventually going to be an int. But in Swift's perspective, we don't know whether converted number is an int or a nil value. So when you're adding 2 to this converted number, Swift is complaining that I don't know whether converted number is an int or a nil value. If it's a nil value, I definitely can't add 2 to it. So you have to do something about this. So how do we check whether converted number is not a nil value? Well, one way to do that is you could just say something like, if converted number is not equal to nil, let's just, for now, print a message saying converted number, or let's just copy this and say, let's say converted number is not nil. And let's just comment this out for now. And we try to run this, and great. We know that converted number is not nil. Okay, great. Now let's move this up here and try to add 2 to it and try to run it. And Swift complains again. It says, even though you did check that converted number is not a nil value, I don't know whether here converted number is a nil or it's not a nil value. It could be nil and I can't add 2 to a nil value. So here we intuitively know that we already checked that converted number is not a nil value. So it's okay to add 2 to it. So how do we force Swift to treat this as an integer and add 2 to it? Well, the way to do that is by adding this exclamation point. This exclamation point tells Swift that we know converted number is an integer, so let's just treat it as an integer and not treat it as an optional or like a possible int. So let's try running this, and great. We added 2 to converted number and it's coming out to 125. In the last section, we saw that if we want to add 2 to converted number, the way to do this would be to first check whether converted number is not equal to nil. And if we know that it's not equal to nil, then forcibly unwrap converted number into an integer and add 2 to it. What if there was a less cumbersome way to do this, more readable way? Well, there is. This is how you would do it. So you would do something, let's remove this 2, and you would do something like this. If let converted number equals int possible number, then let's add 2. And we run it, and great. We see here that 2 was added to 1, 2, 3, and everything's good. So what this means here is that we're creating a temporary constant called converted number, and we're assigning it whatever this conversion turns out to be, whatever the conversion of turning possible number into an int turns out to be. If it's not a nil value, then run whatever is in this if block. Just to see the control flow here, let's add some print statements. So let's say print step 1 and print here step 2, and then let's add another one here. Step 3, and let's run it. Great. Step 1 is run, and then since 1, 2, 3 can be converted into an integer, step 2, this if block is run, and then step 3 is run. What if instead of 1, 2, 3, this was something else? Something like this emoji, which usually describes my state of mind. When we try to run the code here, we see here that step 1 is run, step 2 is completely skipped over, and step 3 is run. Well, why is that? Here, if we try to convert this emoji into an integer, it's not valid, so it returns a nil value. And since it returns a nil value, we're just going to skip over this block and then go into step 3. Another point to remember is that converted number is a temporary constant that we assign only for operation within this if block. So if we try to print out what converted number here is, we couldn't even first of all find it in the dropdown. We try to run it here. It says here cannot find converted number in scope. That's because converted number is temporary. We only use it for the scope of this if block. If you want to add more checks, the operation of these statements, you could just do that by adding a comma after this. So let's just remove this for now since it's out of scope. And let's say if converted number is greater than 100, then let's run all this. So let's remove this, and let's test this code. So let's say something like 200 and run it. Great. We see here that this step is run because 200 is greater than 100 and it's able to be converted into an integer. Let's change this to 5 and try to run this. This step is not run because even though it's able to be converted into an integer, it's not greater than 100. So yeah, this is how you would add more conditions to your if statement after this optional binding statement. So as we saw in the previous section, an optional gives a variable or constant the permission to be a nil value. So if we say something like let possible string equals an optional string, this means that possible string could be an actual string, or it could be nil. If we know that possible string is for sure a string, and we want to assign it to another constant and force it to be a string, we could say something like that. Let forced string, and this is going to be a string, equals possible string, exclamation point. So this means that we're forcing possible string to be an actual string. What if when we start out our program, we have something like this, but we know that it's an optional, right? But imagine after some checks and stuff, we know that possible string will actually be a string. It'll never be nil from this point onwards. It'll be kind of cumbersome to always force it out or check if this is nil, or just add a big if statement after your operations, right? So in Swift, there's a way to implicitly say that we're going to start treating this string as an actual string and not an optional string from this point onwards. So this is how you would do it. So let's create another constant called let assumed string, and let's say string, but with an exclamation point, and let's say an implicitly unwrapped optional string. Here, if we want to assign another constant to this, we want to assign this to another constant, we do something like this. If implicit string, let implicit string, it's actually going to be a string, and let's say assume string. So here, notice that we didn't have to force this assume string to an actual string. We could just use it as a string. You could think about this exclamation point as giving permission for the rest of the program to use this as a non-optional. It could either be an optional, or if you try to assign it to something that's definitely not an optional, it's not going to be an optional. So here we assigned it to this implicit string, which is actually going to be a string. But imagine we assigned it to something else, like optional string equals assume string. And if we looked at what the type of optional string here is, and just to be sure, let's look at what the type of implicit string is. We know it's a string here, but let's just print it out. And we run it. Here, implicit string is a string, and optional string is a string of optional type. So what we're saying here is that if we're going to use assume string as an optional, we can use it as an optional. Otherwise, we can use it as an actual string, not an optional string. So this is a neat way to use variables that you know won't be optionals from one point in the program onwards. One thing to remember is that if you do use this like this and it turns out to be nil, it'll create a runtime error, which is pretty bad. This is how you implicitly unwrap an optional.